Hello everyone. This will be the last video for this lecture and we'll cover 4.2 and in 4.2 we'll graph more polynomial functions. This time we'll practice more sophisticated problems and probably with more efficiency. Okay, so let's do that. We'll pick up one example and graph it, and then I'll give you more examples, or you'll see more examples on the resources which you can practice and check your work. Okay, so let's start. Our function is f of x equals 3x plus 1 x minus 2 the quantity squared. Okay, so first of all, can we say that it's a polynomial? And yes, we will say that yes, it is a polynomial. If we start expanding this, first of all, we can use the formula a minus b the quantity squared here, and we can expand this, and finally if we multiply these two items, eventually we'll have 3x cubed. If you just simplify, you'll get it. If you don't reach this stage somehow, you can send me emails or we can chat about this during our next discussion. Anyway, that's pure algebra. So definitely it's a polynomial. The highest exponent is 3, so your intuition should say that degree is 3. The leading term is 3x cubed, and the leading coefficient is 3 as well. The constant term is 4. Okay. Now, we want to find the x and y intercepts, right? If you remember, we actually did this last time. We'll actually follow the same procedure in this problem as well. So for x-intercept, or rather the y-intercept, we'll actually plug in 0 in place of the function, okay, and solve it for x. That will be our y-intercept. So our main function is 3x plus 1 x minus 2 the quantity squared equals to 0. If we solve it for x, we get 2 from this and a negative 1/3 for this, right? I'm just solving this one in terms of, or rather 4x. So negative 1/3. So my y-intercepts are 2, or rather, sorry. I'm plugging in 0 in place of y. So these are actually my x-intercept. I'm sorry, I did a mistake here. So this should be x-intercept, right? Because I'm plugging in 0 in place of y. So it will be 2, 0 and negative 1/3 0. So these are my x-intercepts. For y-intercept, we just plug in x equals 0 for y-intercept, right? So if I plug in 0 in place of my x, I'll get a 0 plus 1 times 0 minus 2 the quantity squared. So this will be 1. This will be negative 2 squared, which is 4. So overall, it will be 4. So the y-intercept will be 0, 4. Okay, the first job is done. Now, as these are my x-intercepts, we also know that these are my real zeros, right? This is a real 0 of multiplicity 2 because of that. And this one is a real, let me use a different color for it, is a real 0 of multiplicity 1 because we have an exponent 1. Okay, Now, we want to see how can we graph it. Okay, so what we can do is we can find turning points. Now, how can we calculate turning points? Okay, for turning points, we actually have a pretty straightforward formula. So, if you have a degree of n, excuse me, that means the highest exponent for your function is 3, then we'll say that we'll have n minus 1 turning points. Okay, let me write it as TP, turning points. So as we have the degree 3 here for a problem, we'll actually have 3 minus 1, 2 turning points. Now, what is a turning point? Turning point is a point where the graph will change its direction. That means if it was previously decreasing, at that after that turning point, it will start to increase, or the vice versa. That means if it was previously increasing, after the turning point, it will start to decrease. Okay, soon you will visualize it and it will make your life easier. Okay, now let's try and graph it. So first of all, let me use all the informations which I have. Let me use this small area here because this will allow me to see the information and I don't need to scroll up and down every now and then. So I have x-intercepts at 2, 0. Let's say that's my 2. So I have an x-intercept here at 2, 0. And I have another x-intercept as at 1/3, negative 1/3 rather. So let's say that's my negative 1/3. This is not precise graph anyway because it's not a graph paper anyway, but it will actually resemble what it actually looks like. Okay, so that's our x-intercepts. I also know I have a y-intercept at somewhere here. Let's say that's my 0, 4. I also know I'll have 2 turning points. Okay. Now, how can we know whether it's increasing or decreasing? Previously, in our previous problem, we have seen, or rather, we have found out how to find the intervals where the function is increasing, where it's decreasing. That means, in other words, where it's above this line, where it's below this line, right? If we know that, using this number of turning points, we'll be able to graph it. Okay, so we know that for this graph, as the degree is odd because it's 3, right? We know the point, if we plug in a negative point, it will give us something negative. And if we plug in a positive point, it will give us something positive, right? Okay, so what we want to do is we want to take 3 different values. I'll later discuss and say why did I take 3 points and why not less or more. But first of all, we'll take 3 different points and check what it's doing. Okay, how it's actually moving on around it. Okay, so I have an x-intercept at 4, or rather 2, I'm sorry, at x equals 2. So I'll take a value more than that. Okay, I have an y-intercept at 0, 4. So I'll take a value in between 0 and 2. I'll take a value more than 2. I'll take a value within this interval 0 and 2. And also, I know that I have an interval, or rather x-intercept at 1/3. I'll take a value less than that. Okay. So now I'll disclose why did I take 3 values. So as I know, I have 2 turning points, and also I know that these are my intercepts. I'll just take values beyond those and in between those. Okay, this will just make my life easier. Okay, now let's take a value more than 2. If I take, let's say, a 3, for functional value 3, I'll get a 10. You just need to plug in 3 in place of this x's. So 3 times 3 is 9, plus 1 is 10, and 3 minus 2 is 1, so 10 times 1 is 10. So one value could be 310. On the graph, as this is my 2, this will be my 3, this is my 4, so 10 will be somewhere here. So that will be my 310. Okay. Okay, next up, we'll take a value within our next 2 intercepts. So let's take 1, because it's easier to calculate. You need to be wise as well, because if you take bigger values, it will be difficult to calculate when the function is sophisticated. So if you can, take easier values, which will be, I mean, what I mean with easier is easier to calculate. It doesn't require too much time. Anyway, so f of 1, if I plug in 1 in place of this x's, I'll get 4. So the point will be 1, 4. And finally, if I take a value which is less than -1/3, let's take a -1 again. Once again, I am clever enough, I want to be clever enough to save my time. So if I plug in -1, it will be -18. So the point will be -1, -18. So for 1, 4, that's my, oh, sorry, that's my 1. So 1, 4 will be somewhere here, right? Let me use a different color for it. This will be 1, 4. This will be 1, 4, okay? And I'll have a -1, 18. That's my -1. So -1, 18 will be somewhere down here. Let's say that's here, okay? Okay. So as I can see, the graph starts from here, right? It will definitely reach this intercept point. It doesn't intersect the x-axis before it goes past this. So our intuition clearly says it shouldn't go below this x-axis. It will actually turn from here, go upward. That's my 1, 4. I know that it will intersect at 0, 4 because that's my y-intercept. So it will actually go up and again come down at 0, 4, right? Because it's actually going through that point 0, 4. So it will go up and then it will bounce back, okay? And I know that this will go past the x-axis at this 1/3, 0, and it will keep going. So that's my graph. So these are the turning points, as you can see here as well. We have 2 turning points here, and that's our graph. So you can use this to graph a particular function, okay? So that's it from 4.2. That's a smaller section. We will have one more example in the file 4.2, which is available as student resources. as a pptx file. Go there, try the example, second example. Don't see the solution first, try yourself, and then check whether your work is right or not. Okay, and I'll see you next time.